Today we will continue about how to achieve auto scaling of pods in Kubernetes cluster. So based on the load, we want to increase number of replicas. We want to decrease number of replicas. So first let's connect to Kubernetes cluster. So first we'll connect to Kubernetes cluster and we will first see how can we achieve. So I'm connecting to the server where I have a kubectl installed. So as of now, we have these objects. If we see, we created a deployment. Deployment has created this replica set. Now there are two pods. These two pods. And to access these pods, we have a service. If a lot of people are accessing the application, request goes to these pods. So if there is a lot of load on these pods, obviously the CPU and memory utilization will be high, and we should scale. How can we scale? Manually, we were executing some scale commands, kubectl scale commands. But I don't want to execute. I don't want to scale manually. If required, we can achieve auto scaling of pods, so that programmatically it will adjust. Kubernetes will automatically adjust the number of pod replicas based on the load. So we should create some objects for that one. The way we have created a RC replication controller, RS replica set deployment. Similarly, we have one object called HPA, horizontal pod auto scaler. Pod auto scaler. There are two types of scalings, guys. If you take anything, there are two types of scaling. One is, this is again one more object, but we are not discussing here more about this. We have auto scaling. There are two types of auto scaling. One is vertical auto scaling. Second one is horizontal auto scaling. So what is vertical auto scaling? What is horizontal auto scaling? In the vertical auto scaling, what we will do? In the horizontal auto scaling, what we will do? So auto scaling can be achieved in anything, in the infrastructure, in the pods, whatever it is. But now we are only focusing about pod auto scaler. Only we are focusing about pod auto scaler. Now we have created a pod. Maybe you have created one replica. With this, we have a resources, requests, and limits. So you created pod something like this: CPU 10 millicore or 100 millicore, request 100 millicore, memory. Maybe you have said 500 MB request. Limits you said CPU, it can take something like this. I'm just giving 200 millicore. Memory, maybe 1 GB. Something like this. You have a service to access this. So people are started accessing your application via service. People are accessing your application via service. There is a load. You have, let's assume you have only one pod. What will happen? Suppose if 1 lakh people are accessing this application, automatically the load will increase. Automatically the load will increase. The more number of access, right? Automatically load will be increased. So what we need to do now? We have to scale. We have to scale. We have to scale. There are two types of scaling. Not only in Kubernetes, guys. Okay, not only pods. You can scale your servers also. Now I am not talking about scaling of the servers. So your infrastructure in AWS, you can scale your servers. Auto scaling also supports. So here we are talking only about our applications, our pods. Pods are running in the Kubernetes cluster. Now I can scale. How many types of scalings we have? Vertical and horizontal. So what is vertical scaling? I can create a vertical, vertical pod auto scaler also, so that automatically it will scale. What will happen in the vertical, right? It will increase the capacity of your pod. So I mean to say, automatically it will change the limits. It will increase the capacity. Automatically we can scale this from 200 to 400, the limit we can increase from 1 GB to 2 GB, something like this. Vertical, you are increasing vertical. You are not getting another replica, but you are increasing the capacity of this pod. Vertical. In case of horizontal, what we do? What it does basically, it will create a replica of one more pod with whatever capacity you have defined. Replica, it will increase number of pods. Now there are two pods. Now service will distribute the load. Service will distribute the load. Few requests go here, few requests go here. And even after having two replicas, still the load is very high. We can scale again. So service has 3 pods. Then service will distribute the load. So it will automatically adjust the number of pod replicas based on the load, Horizontal, this is horizontal. Vertical, it is increasing the capacity. Horizontal, it is increasing the replicas with that capacity. So horizontal pod autoscaler, vertical pod autoscaler. So which one is better? Can we go for a vertical? Can we go for a horizontal? Why horizontal is preferred? So why horizontal is preferred? Why can't vertical? So where it will create the replica? In whichever server we have some resources. In the cluster will have multiple nodes, right? So in whatever node you have some resources. Unless until you are specifying some conditions exactly in this node you have to create. Otherwise it will create wherever it has some resources. Wherever it has some resources available within the cluster, it will create in node. In whatever node you have some resources. So why horizontal? If you see vertically, if you scale, you are increasing the capacity, but you are running as a single replica, single process. If you do vertical, you are increasing the capacity, but you are running as a single replica, single process. If something goes wrong with that process, it will go down, but it will come up. Right? So instead of having single replica, single process, our application running as a, instead of running as a single process, we are going for a multiple replicas, multiple process for same application. So high availability, right? If you go for a vertical pod autoscaler, vertical scaling, since you are running a single replica, there might be a chance that that may go down. So that's why we are going with horizontal pod autoscaler. One question here, Kubernetes has pod autoscaler concept. So we can define minimum pods, maximum pods. Right? Condition when it has to scale. Right? So when we go for a HPA, horizontal pod autoscaler, when we create that object, we are going to define minimum pods, maximum pods condition when it has to scale, something like if CPU utilization is greater than some percent, or if a memory, some condition when it has to scale. If the memory is greater than something like 85% is already there, right, on these pods. And target, we are going to mention about target object, which object it has to scale. Here we are going to mention replica set or deployment, which deployment it has to scale based on this condition. Which deployment object or which replica set object this has to scale based on the condition, and what is maximum pods it can create. So we can define this information in one object called HPA, horizontal pod auto scaler. This is one more Kubernetes object. You already know how to create a deployment. You already know how to create a replica set. You already know how to create a replication controller. For that replication controller, or for that replica set, or for that daemon set, we are going to create a horizontal pod auto scaler based on some limits and conditions. But my question here is, will it able to scale your infrastructure? Suppose there is a lot of load on these pods. I am trying to increase the pods. What if this nodes doesn't have any resources available? Does horizontal pod auto scaler or vertical pod auto scaler, will it able to scale your infrastructure? What I mean to say here, right? You are trying to, you created a horizontal pod auto scaler, you created a vertical pod auto scaler. What if your servers, your nodes doesn't have enough memory, enough CPU? Will it able to create the pods? Will it able to increase the pods? And will it able to increase your infrastructure resources? This pod auto scaler, provided you have enough number of resources available in your cluster, this pod auto scaler will increase the pods and decrease the pods. Then how can we achieve cluster auto scaler? Cluster scaling, I mean to say infrastructure scaling. So we will see what is the problem with the self-managed Kubernetes cluster. At the end of this, what is the problem with self-managed Kubernetes cluster? There are different ways to set up a Kubernetes cluster, like EKS, AKS, as we discussed, GKE, we already discussed in the beginning, right? When we go for this, we can create a one more component called cluster autoscaler. Cluster autoscaler. When we create a Kubernetes cluster using EKS or AKS or GKE, then I can create a one more component called cluster autoscaler. The name itself is saying cluster autoscaler. When we go for this Kubernetes cluster, managed Kubernetes services, when I go for cluster auto, this one, when I create a cluster autoscaler, what will happen? Pod autoscaler will try to scale number of pods. Suppose these pods, the scheduler is not able to find any nodes, none of the nodes has resources. So what happens? This cluster autoscaler comes into picture. Whenever Kubernetes find something, whenever Kubernetes see some pods are in pending state because the resources are not available. Whenever Kubernetes find basically this cluster autoscaler, if I deploy this cluster autoscaler, whenever it sees the pod is in pending state and it is pending because of no resources available. This cluster autoscaler will increase the nodes. It will scale the cluster. It will scale the cluster. It will increase the nodes. The cluster autoscaler will increase the nodes. When it will increase the nodes, if this cluster autoscaler found that there are some pods in a pending state because of resources are not available, this cluster autoscaler will work with respective cloud. This cluster autoscaler will work with respective cloud like AWS or Azure or Google Cloud. It will scale our cluster. It will increase the nodes. It will increase the nodes, number of nodes. So it will increase the number of nodes so that you are getting new nodes. So this guy, the scheduler, can schedule the pods in these new nodes. So try to understand there are two types of scaling: infrastructure scaling and application scaling. If I go for a containers, right, our application is running as a containers. In Kubernetes, those applications are running as a pods inside, as a containers inside the pods. I can scale the application, pod auto scaling. Automatically, I can scale our application replicas, pod auto scaling. But what if the cluster doesn't have enough resources? The pod autoscaler cannot increase the servers, cannot increase the number of nodes. Pod autoscaler only will try to increase the pods. But if doesn't have enough resources, this cluster doesn't have enough resources, it will not able to scale. It will go in a pending state. The pods will try to increase, but pods will be in a pending state. Why pods will be in a pending state? It can be because of resources not available. So in that case, you need to increase your nodes. You need to scale your cluster. If I go for a Kubernetes cluster like this, there is a concept called autoscaler, cluster autoscaler. That cluster autoscaler will scale the cluster whenever cluster is running out of resources. High availability. Application high availability, infrastructure high availability. When application will be highly available? If my infrastructure is not highly available, does my applications will have high availability? We are running our applications on top of infrastructure, right? My infrastructure should be highly available. Then I can achieve high availability in the application. So be more clear on this one. Don't get confused, right? If I use pod autoscaler, right, which means the cluster also will be scaled. No, cluster will not be scaled. Cluster will not be scaled. And try to understand what is difference between what is self-managed Kubernetes cluster and what is managed Kubernetes cluster. Self-managed. If anything goes wrong, I need to manually manage. If worker goes down, I need to fix myself. If master goes down, I need to fix myself. And we cannot achieve this like cluster autoscaler. We cannot create a cluster autoscaler to increase the cluster. But in self-managed Kubernetes cluster, we can create a pod autoscaler. In self-managed Kubernetes cluster, we can create a pod autoscaler provided you have enough number of servers and enough number of resources. But this is cluster autoscaler will not work. And if master goes down, you have to fix yourself. If worker goes down, you have to fix yourself. But when I go for a managed Kubernetes cluster, like EKS, AKS, GKE, COPS, so I no need to worry about control plane. Control plane, I mean to say master, API server. It is highly available. And I no need to worry about workers. If one worker goes down, I will get another worker automatically. If I create a cluster autoscaler component, if the cluster is running out of resources, automatically it will create a new worker node and it will join that node to the cluster. So this is managed Kubernetes cluster like EKS, GKE, AKS. In self-managed also we can go create a pod autoscaler. In cloud, this managed services also we can create pod autoscaler. But what is the advantages with managed Kubernetes clusters? It's a highly available Kubernetes clusters. Our infrastructure will be highly available. If something goes wrong with your nodes, it will be automatically created. And if your cluster is running out of resources, if I have created a cluster autoscaler, then that cluster autoscaler will try to scale our cluster. So when we go for EKS, I will try to make one video. There we can understand how to create a cluster autoscaler. For now, we are trying to discuss about only pod autoscaler. Okay. So I just want to give an overview how it works. So now let's try to do this. We'll try to create a pod autoscaler. Automatically pods has to be increased for some application. You can create HPA, horizontal pod autoscaler, for any object, guys, any replication controller, any replica set, and any deployment. But can we do HPA for daemon sets? Can we create a horizontal pod autoscaler for daemon sets? No. Daemon set is basically one copy in each and every node. So we will not increase, we will not scale the pods. One pod, one node. It is not only one pod in entire cluster. It is not something like this, right? So it is like the daemon set will have a one pod in each and every node. Suppose if I have 10 nodes, if I create one daemon set, how many pods will be there for the daemon set? If I have 10 nodes, right? And if I create one daemon set in that cluster, how many pods will be there for the daemon set? 10. I mean to say each node one pod. So we discussed when we will go for a daemon set, when we will go for a deployment, what type of applications we will deploy in a daemon set. So I can create a HPA for any application, but I will use some demo application. Guys, I can create a pod autoscaler for this deployment also. I can create a pod autoscaler for this replica set. If I have created a replica set directly, I can create a pod autoscaler for this replica set also. I can create a pod autoscaler for this deployment also. But I will use some demo application. so that I can demonstrate correctly how it can scale. So let me delete all these things before I deploy that application. Why I am deleting? Why can't I demonstrate that one without deleting? Because the capacity of my nodes. What is the capacity of my nodes in this Kubernetes cluster? What type of machines we have created? So T2 dot micro, worker machines T2 dot micro. So just 1 GB RAM and 1 core processor. If I already have lot of pods and I cannot demonstrate the scaling because already your worker nodes is having lot of pods. If I try to deploy one more application, if I try to deploy HPA, pods may not able to come up. Pods may go into a pending state because we may run out of resources. So to demonstrate that HPA, I removed whatever applications which is already running in this cluster. But in real time, we will not go with these configurations, right? In real time, we will not have your servers like 1 GB servers. We will go with some high capacity so that it can scale up, scale down the pods. So now, but let me show you before that what is the required components. So this HPA, let me open the document so that you can understand. So HPA, as I discussed, right? The horizontal pod auto scaler automatically scales the number of pods in a replication controller or in a deployment or in a replica set based on what? This is more important. Based on the observed CPU utilization or memory utilization. So this HPA, horizontal pod auto scaler, automatically scales the number of pods in a replication controller or a deployment or a replica set based on the observed CPU utilization or memory utilization. So what is required for HPA to take a decision? What is required for HPA to take a decision? The current load on that pods, on those targets. So this is one kind of a controller, horizontal pod auto scaler. So this will determine the behavior. This controller will periodically adjust the number of replicas based on the average CPU and memory utilization. So it is required, the HPA require the load, the current load on those containers, those pods, right? So who will provide the information, right? The HPA requires some input. HPA requires some input. Horizontal pod autoscaler requires some input, something like what is the CPU utilization of your container, your pod, what is the memory utilization, right? Someone should be able to gather all those information. If you remember, in Docker, we have one command to check the CPU utilization, memory utilization. What is that command we used? So that it was showing what is the CPU load, memory load on a container. What command we used, right? Docker stats. Docker stats, it was showing the load, right? Similarly here, we have some commands, but by default, it is not going to display. Here we have a command called kubectl top nodes, top pods. Kubectl top nodes, kubectl top pods. It used to display the load on the servers, load on the pods. But by default, this Kubernetes cluster doesn't have the component which will gather the metrics. Metrics, it is kind of a metrics only, right? Your pod metrics, your node metrics. So if you see what it is saying, metrics API not available. By default, this Kubernetes cluster doesn't have some component which will gather those metrics. If you see, I have API server, I have a scheduler, I have a control manager. Similarly, we can deploy one component called metric server. That metric server will gather the metrics. Those metrics are important for horizontal pod autoscaler or vertical pod autoscaler, whatever it is. If you don't have a metrics, will it able to decide when it has to scale, when it has to scale up, when it has to scale down? If HPA doesn't have a metrics, this is one program basically. This is one program. Periodically it will execute. It will take decision based on the metrics. But as of now, right? Let's see if you see. Is it able to gather the metrics? Basically, is it able to display the metrics? Basically, kubectl top pods will display the metrics, the CPU and memory utilization of pod. Kubectl top nodes will display the node metrics. By default, we don't have the component which will gather the metrics. So earlier we used to have a heapster. Let me show you. Earlier we used to have a heapster. So what it is saying, this is not there as actually as of now. So it will try to gather CPU, memory, right? So we need to deploy one component, metric server. So before 1.8 versions of Kubernetes, we used to have by default this one, heapster. Tools for monitoring resources, right? Before 1.8, of Kubernetes, right? We used to have one component called heapster. So let me search directly with heapster. So let me show you some somewhere, wherever it is. So here we don't have information about heapster. That is fine. Now heapster is deprecated. If you see before 1.8, right? It is a add-on. It will gather the metrics from your pods, which is deprecated. Basically, before 1.8 Kubernetes versions, if you install Kubernetes version which is less than 1.8 version, by default we used to have one component called heapster. That heapster is basically again doing same job. It is trying to gather the metrics. Now it is deprecated. By default we are not having that heapster. By default we are not getting that heapster component. The way you have a API server, the way you have a scheduler, before 1.8 we used to have a heapster that used to gather the metrics. Now they have deprecated. By default it is not coming as part of your control plane. Now we need to deploy a metric server. We need to deploy a metric server. If you see what is metric server, what it does, it is deployed. What it does basically, it's kind of an aggregator for resource usage. It will gather the information. Metric server collects metrics from kubelet on each node. So it will collect metrics from kubelet, which is running on each node, right? Metric server will connect to the kubelet. It will gather information. How many pods you have? What are the load on those pods? And it will be calculating what is the load on that node. So by default, that metric server is not there. That's why it is saying metrics API not available. So HPA will interact with metric server to identify CPU and memory utilization. Earlier, by default, we used to get one component called heapster. Heapster is kind of one program. It used to do the same thing, whatever metric server does, but heapster is deprecated now. What is metric server? Metric server is an application that collects metrics from pods, that collect metrics from objects such as pods, nodes, right? So metric server will talk to the kubelet, which is running in each and every node, to gather this information. So metric server can be installed as an add-on. Metric server can be installed as an add-on. So you have to deploy the metric server as an add-on. Before deploying, let me show you. It is like one deployment. It is like one daemon set, something like that. So if you see, I am maintaining all those YML files in our GitHub itself. Our Kubernetes is 1.8 plus. If you see here, we are applying lot of YML files. If you see this one, I will come to this, guys. What is service account? We have not discussed what is service account. So I will come to this later. Now, if you see, what is this? We are trying to apply all these YMLs to deploy a Kubernetes metric server. What are we doing here? What are we doing? We are deploying. We are using a deployment. From which image? What is the image? Which image we are using, if you see? metrics-server AMD 64. This is one Docker image. This is one application, basically metrics server we are deploying. But who implemented this image, this application? What is this? Kubernetes. So we are deploying this metrics server also in a Kubernetes cluster as a deployment. You know, deployment will create a replica set. And here I have not mentioned number of replicas. So how many replicas it will create? One replica. So let me briefly give overview about service account. What is service account, right? And if you see here, I am creating one service account with this name, metric server. And here, when I am creating a pod, under pod template, here I am giving the same name, service account name. What is the use of service account? Why it is required? What it has to do? Basically, what it will do, guys, this metric server, it will gather the metrics. It will gather the metrics, right? It will gather the metrics by talking to the API server, by talking to the kubelet. But will it able to talk to kubelet, or will it able to talk to API server first of all without having proper permissions? Does any application can talk to API server and modify, or will it able to gather the information from API server without proper permissions? This application has to talk to the API server. This application has to talk to the API server. By default, your applications will not have a permissions to talk to the API server, because it has to read your cluster resources. This application has to get the information about your cluster, Kubernetes cluster resources, like it requires access to the pods, it requires access to the deployments. By default, this will not have a permission. We are giving a permission via service account. This is like a user, service user. It is like a service user you are creating. And you are attaching that service account to this container. But where are we giving the roles, permissions, right? If you see, this is where we are doing a role and role binding. We are creating a role. We are creating a role here. We are creating a role, not here. If you see, we are creating a role. We are giving permissions. We are giving a permissions to that role. We are giving a permissions to pods. We are giving a permissions to nodes. We are giving a permissions to stats, node statistics. We are giving a permissions to namespaces. What type of permissions we are giving? We are only giving get, list, watch. We are creating a role. We are binding that role with this service account. This is a role in Kubernetes. We will discuss in detail in a separate topic. There is a topic called RBAC, but I want to give an overview. We are creating a role. We are binding that role with the user. Here user is nothing but a service account. If you see, we are binding here. We are linking between the role and user here. Basically service account. And this service account, we are mapping with our container, so that this container will able to talk to the API server to get the information. So we have to apply all these YML files to deploy metric server. So we are maintaining this in our GitHub itself. You can clone this and you can apply. Here also I have a document. What is metric server, right? The steps, how can we deploy metric server? So let's deploy a metric server. So it's part of our project, our GitHub itself. If you want to see more details, you can go for official documentation here. You have official documentation link, right? So let me take this one. So let me clone that YMLs and I will apply. So I have cloned that basically. Inside this, I have some folders, right? I went inside that metrics folder. And since my Kubernetes cluster is 1.8 plus, right? So I'm trying to apply all the YMLs which are part of this folder. I am inside this folder and I have this folder. As part of this, again, I have a lot of YMLs. Under 1.8 plus, I have a lot of YMLs. So I am trying to apply all these YMLs. We are trying to create a deployment. We are trying to create a service. If you see, we are creating a service. We are trying to create a deployment, right? And we have some role binding concept that we will discuss in a separate session. Now let me apply. If you see, it has created a deployment. It has created a service account. It has created a role binding. Right? So we will try to see whether will it able to gather the metrics. Under which namespace I have deployed this? Under which namespace I have deployed this metric server? Under kube system namespace, because if you see YMLs, you see deployment YML. So I have mentioned the namespace name. Under kube system, it has deployed. Now let's try to execute that command, kubectl. Now is it able to gather the metrics? I don't have any pods in the default namespace. Let me use some other namespace. Now, do you see, is it able to gather the metrics? How much CPU, how much memory each node is using and how much is available on each pod? What is the memory utilization? What is the CPU utilization? Now I have a metric server. So now we will deploy our application. So you know how to create a deployment. You can create a HPA for any application, guys. I am using just one application, that's it. I am using this image. I'm using this application to demonstrate. You can create a HPA for any application, whatever application you are deploying in your Kubernetes cluster, right? You can create a HPA for that. So here we are having one deployment. I'm trying to create a deployment. You can create HPA for any deployment, any replica set, any replication controller, which is already there in your cluster. This is one deployment. This is one application, that's it. I'm trying to deploy one simple application. We are creating a deployment, right? What is new here? We know all these things already. We know all these things already. What is new here? We discussed this. While creating a pods, while creating a containers, for container I am saying resources. Here we are defining a resources, request and limits. Request and limits. Can I have something like this? Request is something higher, limits is lower. Can I have something like this? Request is higher, limits is lower, right? You cannot have, it will give error. Okay. So limit should be greater than or equals to request. Limit should be greater than or equals to request. So now I am setting this. I am deploying this deployment. You can ask me, sir, why can't you scale up, scale down the Java web app pods? We can do that, but I cannot increase the load on that application programmatically. So that's why I'm using this application. That's it. I can scale up any application. I can scale up Java application, Java web app, that image, or I can scale up Spring Boot application, whatever. But I cannot put that much load on those applications. That's why I'm using this one. So I'm just creating one deployment. That's it. In a default namespace. So I created a deployment created a replica set, and we are getting the pods. Still it is creating a containers. Now it is very simple application. It's very simple application. When I am accessing, it is just displaying OK. So this is very simple application. Just I want to demonstrate horizontal pod auto scaler. We created a deployment. We have not created a service as of now. We have not created a service as of now to access within the cluster or outside the cluster. So let me create a service. You know how to create a service also, right? So I am creating a service. In the same YML also we can do that. Separate it. So if you want to access outside and see, maybe you can change it to node port. If you want to access outside and if you want to see what it is returning, you can change it to node port. Otherwise, leave it cluster IP itself. Now let me apply. Now I got a service also. So within the cluster, I can access using this service name. I can create some pod from temporary pod. I can access using this service name. From outside, sorry, this service name. From outside, if I want to access node port and node IP, so this is the node port. You can access using master, worker, whatever it is. The port is 32528. This is very simple application. It is just returning OK. We just created a deployment. We just created a service. Do you see anything on this? Any load? As of now, these are using just 1 millicore of CPU and just 13 MB of memory. These pods. Pod has a container. This container, that container is using just 1 millicore and 13 MB. So now there is no load. Now if I increase the load, will it able to scale or we are missing something still? Now if I try to increase the load, will it able to scale automatically? Or am I missing something still? Will it able to scale automatically now if I increase the load? Yes, no, or am I missing something here? Why it will not able to scale? Why it will not able to scale? If you understand the concept correctly, what objects I have created so far? I have mentioned the limits. If you see, I have mentioned the limits. I have mentioned the request. If you understand the concept correctly, I created a deployment. That is fine. Limit can be same as request. That is fine. Limit can be same as request. If you just define the limits, will it able to scale? I just created a deployment. Who is going to automatically scale? Deployment will be able to automatically increase, decrease. Who will control this scaling? Horizontal pod auto scaler. Deployment will not scale up, scale down, guys. Deployment will not automatically scale up, scale down. Horizontal pod auto scaler, that is one object. Did I created a horizontal pod auto scaler as of now for this deployment? That's what I am saying, right? You have to focus. I would have directly take this YML and I can apply. Why I am not going that way? Because you should know who is doing what. That's why I discussed almost last 40 minutes, right? the definition itself, the horizontal pod autoscaler automatically scales the number of pods in a replication controller in a deployment. As of now, I just created a deployment. Did I created a horizontal pod autoscaler? Horizontal pod autoscaler can be created for a deployment, can created for a replica set. So we just have deployment. Don't get confused. If if I create a deployment or if I create a container with resources, which doesn't mean it will scale up. Did I mention how many minimum pods I required, how many maximum pods it can scale? Or when to scale, how to scale? We have not defined so far. So we have to create an object. Now, if I increase the load, it will not scale up. It will not scale down. Because we don't have a HPA, horizontal pod autoscaler. There is a one more object. Do I have any HPA object as of now? Horizontal pod autoscaler in the short form. Do I have any HPA? I need to give full vertical. Do I have any HPA as of now? If you see horizontal pod autoscaler, we don't have. Even though you increase the load, it will not scale up. Always it will be 2 pods. What will happen if you don't scale? What will happen if you don't scale? The performance. If it is running, if this pod is running out of CPU, it will be very slow. I have set the limit. How much maximum it can use? Limit 100 millicores. And if it is running out of memory, if it is running out of memory, it will kill the process. If it is running out of CPU, the performance will be very slow. It will not respond properly. Right? Let me show you. I don't have a HPA object created as of now. And I want to increase the load. How can I increase the load? Can I ask 1 lakh people to access this application now? Do I have those many peoples? What I will do, guys? I will create one temporary pod. I will create one temporary pod. I will programmatically increase the load. So what I will do, I am creating one temporary pod interactively. Now I am using interactive imperative commands. Instead of using YML, I am using command. I am saying using this image, create one pod interactively. So it will create a pod, it will create a container, and we are going inside the container, inside the pod. Now here, I can access using service name. So if you see, if I execute something like this, I will get a response. This is my service name. I should not give do. This is my service name. Using service name, we are able to talk to that pod. Now infinitely, what is this? While true, infinitely I am trying to access that one. Programmatically, I am increasing the load. Now let's open another tab where I want to see the load. Let's open another tab. I will connect to master, basically see, kubectl machine. Now let me show you cubes. I will watch kubectl top pods. How much CPU load is there as of now? Because I am trying to put the load. If you see programmatically, infinite loop. I am accessing that application, that service. I am accessing using service name. Request goes to service, service to pod. How many pods as of now that service has? How many endpoints that service has as of now? How many endpoints that service has as of now? How many pods? Only one pod. Huh? If you see, what is this? 2. Now what is the load? If you see here, what is the limit I have set for this pod? 100 millicore. 100 millicore. Now already it is using more than like 40, 70, like 40. One is 47 millicore, one is 36. It's keep on building the load. Programmatically, infinitely, it is increasing the load. After some time, it may go above 75, 80. What will happen? If it reaches 80 or 75, the performance of your application, your process will be very fast. Now already you see here, it is not so fast. So what we have to do in this scenario? If you see already one is reached 70 millicore. What we have to do? We need to scale, but I don't want to scale manually. If I scale, what will happen? Instead of 2 pods, if I scale it to 3 pods, what will happen? Request is going to service. What service does basically? Service will act as a load balancer. It will distribute the load so that instead of 70%, it may come down because you have a total 3 pods. So service will distribute the load. Service has 3 endpoints. If I scale, service will have 3 endpoints and it will distribute the load. As of now, it has only 2 pods. Whatever request is coming, it is routing only to those 2 pods. So now I don't want to manually scale. That is where HPA comes, horizontal pod auto scaler. So let me stop this. Let me press Ctrl C here. I want to come out of that pod, temporary pod. Let me type exit. Okay, now it's deleted. Now I want to scale these pods automatically based on the load. If you see, still I have only 2 pods for this deployment. kubectl get deployment. I have only 2 pods. Now I want to create a horizontal pod auto scaler for deployment so that it will increase the pods, it will decrease the pods based on some target. So that is where we are going to create this object. What is this? This is one more Kubernetes object. This is one more Kubernetes object. What kind of object it is? Horizontal pod auto scaler. HPA, horizontal pod auto scaler. If you see, this is the API version for the horizontal pod auto scaler. This is the name. I can give any name. Under spec, what is this? We are creating horizontal pod auto scaler by specifying what? Minimum replicas, maximum replicas. What is minimum? What does it mean, right? At any point of time, how many minimum pods it will maintain, even though there is no load? Always there should be a whatever minimum replicas. Here, if I mention 2, always how many pods it will maintain minimum? 2. If I mention 4, at any point of time it will have 4 pods, even though there is no load. Minimum pod counts, maximum replicas. What is the meaning of maximum? Maximum up to how many pods it can scale. Even though there is a lot of load, if I mention here as a 5, how many maximum up to how many pods it can scale? Only 5. Even though there is a lot of load on all the 5 pods, it will not create a 6th one, because that is your maximum condition you have given. If I say 10, it can go up to 10 pods. If I say 20, it can go up to 20. Okay. So here we are saying 5. Always 2 pods will be there. Up to 5 pods it can scale. But when it will scale, where are we defining that threshold? So where are we going to define the condition? When it will scale, it has to take some decision. Where are we defining that information? If you see under metrics, we can define metrics based on the CPU. You can define metrics based on the memory. But here, based on what metric I am defining? Target CPU utilization. It is in percentages. So 50%. 50%. Right? So what is the limit I have given? 100 millicore. 100 millicore. So what is 50% of 100 millicore? 50 millicore. The moment it reaches more than 50 millicore, it will start scaling. Sir, why you have given 50? Because I cannot put that much load. I have given 50. Maybe you can go for 75 to 80%. 75 to 80% in real time. So how it will take? Is it going to take at the pod level? Is it going to take at the deployment level, average? Is it going to consider 50% in individual pods or 50% of average of your deployment pods? And most important, it is not going to take pod level. It is not going to take pod level. Most importantly, it will take average. Most importantly, where I am linking. This horizontal pod auto scaler is for which one? Where I am linking. Where is the link between your maybe replica set or deployment and horizontal pod auto scaler? Where is the link? For which deployment or for which replica set you are creating this HPA? If you see here, what is this? Target, scale target. For what object I am trying to create a HPA here? Deployment. What is the link here? If you see, this is my deployment name. Same name you see here. This one. So for this horizontal pod auto scaler, we are creating for this deployment. So where can we see the API versions? We just need to check the official documentation. That's it. So you just need to check the official documentation. That's it. So what here you will see like what is the API version of that horizontal pod auto scaler. So you will see an example also. If you see, this is something like this, official documentation. So now let me create a horizontal pod autoscaler. So maybe let's see. So in same YML, I'm again creating that object also. So if you see, this is where you are linking. I may get a error. Let me remove this. kubectl apply -f. Now kubectl get HPA. It is still trying to find the current utilization. This is the target. It is trying to find the current utilization. It may take some time, just a fraction of seconds. Now target is 50%. What is the current load? 1%. And if you see minimum pods, maximum pods, what does it mean? This replicas, it is showing us to what does it mean? Minimum, maximum. This is current. How many pods you have? This minimum here, maximum here. What does it mean? Replicas here it is showing us to the current. So now if you see, there is no load. The average, it is going to take average. So 1 plus 1 by 2, basically total number of pods, sum of this by number of current replicas. So what is the average now? 1%. Now whenever there is a load, automatically it will increase. Let me show you. Again, I am creating temporary pod. Again, I am creating temporary pod to increase the load. Now let me infinitely execute this one. Now if you see, slowly we are building up the load. As of now, we have only 2 pods. Request is going to service to the pods. Slowly the load will be increased. In the meantime, let me open another tab. Let's watch the pods. Let's watch the pods also. Watch kubectl get pods. As of now, we have only 2 pods for this application. We are increasing the load. What is the, now if you see, it will take average 61 plus 38 by 2. 61 plus 38 is basically 99 by 2. So is it more than the target? 99 by 2. Is it more than the target? No, right? So it reaches, if it reaches more than 50, the average, instead of 2 pods, right, it will scale 1 more pod. Who will do that? Who is doing that? That HPA, horizontal pod auto scaler, will periodically adjust your number of pods based on the observed CPU and memory utilization. So let's wait for some time. Right. Now it crosses more than 50 average. After some time here, you can see one more pod. In another tab, I am just watching. If you see already, do you see, is it started when it has created a third pod? Almost 30 seconds ago, already it has created. Why it has created a third pod? It has created a third pod because there is a lot of load. It is more than our target. Now, this guy, we are accessing a service. So now request goes to service. Service has how many pods? Now you see service has 3 pods, right? Now load is distributed. If you see, now earlier one of the pod was having almost 68 or 70%. Now the load has come down. The load has been shared. The load has been shared. The load has been distributed. Now if you see, one pod is having 23, one pod is having 48, one pod is having 27. Now, what is the average now? 23 plus 27, 50, 50 plus 48, 98, 98 by 3. What is the average? 98 by 3. Now 3, total 3 pods. The average, right? So 33. It's not out of the target. It is not out of the target, right? If you see, now let me show here itself. kubectl get HPA. So is it more than the target as of now? If you see, what is the number of replicas as of now? 3 replicas. Now, since there is, I cannot put more than this much load. If I have created a one more temporary pod, if I open one more tab, if I create a one more temporary pod, and if I parallelly run this one again, maybe the load will be again increased so that I may get a 4th tab. Provided you have enough resources on your cluster. So I have a lot of memory, right? Lot of, if you see, hardly 174 millicores, we have just 8% utilization CPU. I have a lot of CPU still. I can scale up. What if you are running out of resources in your cluster? Your nodes itself doesn't have enough memory. Horizontal pod auto scaler will try to scale the pods. What if your nodes doesn't have enough CPU and memory? The pod will go to pending state. So that is where the cluster auto scaler comes. When we go for a EKS or AKS, that is where cluster auto scaler comes. If your pods are in a pending state because of no resources available, the cluster auto scaler kicks in and it will increase the nodes. It will increase the nodes. Pod auto scaler is different. Cluster auto scaler is different. So in self-managed Kubernetes cluster, I was able to create a pod auto scaler. I will be able to create a pod auto scaler. In our on-premises data center servers, suppose you are using on-premise data center servers, you are not using cloud, you are not using managed Kubernetes clusters. Can I create a cluster auto scaler in the self-managed Kubernetes cluster? How can we create a cluster auto scaler in a self-managed Kubernetes cluster? What is cluster auto scaler? It will scale the nodes. In your own data center, will you be able to scale the servers dynamically? Nodes is nothing but your infrastructure, your servers. Will you be able to scale? in your data center dynamically, will you able to scale the servers, right? That is why people are going for a cloud. So in self-managed Kubernetes cluster, we can use autoscaler, pod autoscaler, but not cluster autoscaler. Your infrastructure has to support. So this is about horizontal pod auto scaling. Okay, it's very important to understand how it works, so that you can apply all these concepts to achieve high availability. So tomorrow we will continue. Yes, whatever pods created by HPA, the resource limits will be same as what we defined in the pod deployment. Basically, HPA, what will happen, right? HPA will internally execute same command. HPA will internally execute kubectl scale. If you are created a HPA for deployment, your deployment name, and it will increase replicas. If it is currently 2, it will scale to 3. If it is 3, it will scale to 4. That is just one piece of code. Programmatically, it will adjust. That's it. So if you want to achieve horizontal high availability at the master level, you have to go for a multi-master Kubernetes cluster. If you want to achieve high availability at master, as of now, we have a single master. If the master goes down, what will happen? What are running in a master? The entire Kubernetes control plane. Where our Kubernetes control plane components are running, like API server, scheduler, control manager, etcd. Where those are running? In the master. If I have a single master, if the master goes down, which means your control plane is down. If your control plane is down, your API server is down, your control managers are down, your scheduler is down. Whatever pods it was running in the workers, it will work. But if it goes down, no one will be there to manage or monitor. If you want to achieve high availability in the master, you should go for a multi-master Kubernetes cluster. So try to practice whatever we discussed today. Tomorrow we'll continue with volumes. So far we discussed what is pod, what is replication controller, what is replica set, daemon set, deployment, service. Service we discussed so far, cluster IP, node port. We have one more type called load balancer. We will discuss later. This yet to discuss. And today we discussed about HPA, horizontal pod auto scaler. So we'll continue discussing about volumes from tomorrow. Tomorrow we'll start with volumes. Right? Still we have a lot of concepts, guys. Config map and secret. We have a liveness probe. And readiness probe. In volumes also you have static volumes, dynamic volumes. In volumes you have a lot of types, PV, PVC. So we will discuss that. Then RBAC, role-based access control. We discussed today, right? Service account role binding, those concepts. And we have ingress. Right? There are still lot of topics we will discuss slowly one by one. But you have to practice whatever we are discussing regularly. If you don't practice, you will get confused why we are creating these many objects. Each object is for some requirement, right? So you should be able to understand all the concept. You can understand only by practicing. Okay, try to practice. And Kubernetes, the way you have a kubectl, we have a dashboard. If required, you can set up a dashboard, Kubernetes dashboard. There is a video in our YouTube channel. If required, you can set up a dashboard. Like the way you have a GUI for this data, AWS, right? From where I can see how many servers I have, right? If required, I can delete, I can terminate, right? Similarly, Kubernetes also has a UI, Kubernetes dashboard. If required, you can set up a dashboard. So this is the link, Kubernetes dashboard setup. You can follow this video and you can create a dashboard. But we will not manage Kubernetes clusters using dashboard, but by logging into dashboard, you can get an overview about your cluster. How many resources are there in your cluster? What is happening in your cluster? You can get an overview by logging into dashboard, but we will not use dashboard to deploy the applications. We will use command line CLI only. Okay. So go through this video. We'll continue tomorrow. Okay. Thank you. That's it for today. We'll continue tomorrow with values.